Here's problem 3712. An interference pattern is produced at a point P on a screen as a result of direct rays and rays reflected off a mirror as shown in the figure. If the source is 100 meters to the left of the screen, 1 centimeter above the mirror, and the source is monochromatic, wavelength of 500 nanometers, find the distance y in millimeters to the first dark band above the screen. So looking at this, we have a y value, which is our distance to point P on the screen. We have the distance L, which is the distance to the screen. That's given as 100 meters. And we have a source located at this point, and then there's also the image of that source located behind the mirror, and that image is acting like the second source. So in other words, this reflected ray seems to be coming from that location where the second source is. And the distance between these two locations would be our distance between the slits, so to speak. So it's really like a two-slit diffraction pattern, interference pattern. The only change is that there's going to be a phase reversal for the reflection of the ray off the mirror. So where we used to have constructive interference, we actually will have destructive interference, and vice versa. This whole apparatus is called Lloyd's mirror. And we will get dark fringes at lambda L over D times M. And we will get constructive or bright fringes at the usual place, lambda over D, or lambda L over D times M plus 1/2. So we want to find the location of the first dark band above the screen. So that location, Y dark, is going to equal the wavelength, which is 500 nanometers, 500 times 10 to the minus 9, times L, which is given as 100 meters, over D, which is the distance between these two sources. Now, source is 1 centimeter above the mirror, but D, the distance to the image, is going to be twice that. So it's going to be 2 times 1 centimeter, or 2 centimeters distance between these two sources, the image and the real. So our D is going to be 2 centimeters, 2 times 10 to the minus 2. And then, of course, M is going to be for the first dark band. So if we put all this in there, what do we get? .5 times 10 to the minus 3 meters, or 2.5 millimeters. 2.5 millimeters up on the screen from the center point is going to give us the first dark band above the screen.